Hello, hello, hello everybody, and welcome back. We're looking at the 2009 Grade 10 Cayley Math Contest, and we're up to question number 19. That's what we'll be tackling in this video. How many integers n are there, with the property that the product of all the digits of n is 0, and n is between 5,000 and 6,000 inclusive? It's a less than or equal sign here. So 5,000 and 6,000 are absolutely allowed, and they satisfy this because 5 times 0 times 0 times 0 is 0. Okay? Now the first thing that you should know is, well, we're going to need zeros. Okay? You can never have a product of a bunch of non-zero things equal to 0. At least not until you start doing very advanced math that do not use the number systems that we are comfortable with. And it's a long way off, nothing to worry about. Okay? We're working with nice, clean, single digits, and the only way to multiply a bunch of single digits and have the end result be 0 is if at least one of those digits is 0. Now, I say at least one. 5,000 is 5 times 0 times 0 times 0. Well, just that one 0 there is enough to get 0, but we have 3 of them along for the ride. So, we know we need at least one 0, but more zeros would be fine. Now, I can't have a leading 0. It's got to be between 5,000 and 6,000, so the first digit's either a 5 or a 6. But then I got 3 other digits to play with, and any of them could be zeros. We could have 1 0, we could have 2 0, or we could have 3 0. So what I'm going to do is I'm going to break this down and count different ways. I'm going to count the number of ways where we just have 1 0, where we just have 2 zeros, and where we just have 3 zeros. I'm going to start with the 3 0 one, or the 3 0 case. 3 zeros. Okay. And that's got to be, well, either a 5 or a 6, and then 0, 0, 0 is my number. Well, there's really only 2 that are going to fit the mold, 5,000 and 6,000, so 2 of these numbers. That's it. Very simple case, just to get us started. Now, for 2 zeros, again, I either have a 5 or a 6. Well, it'll never be a 6 anymore. It'll have to be a 5. Why? Well, if it were a 6 and n is less than or equal to 6,000, then we have to be looking at 6,000, but we've already dealt with that one right here. We've already counted 6,000. So we know every number from now on is going to start with a 5. But where do these 2 zeros go? They could go in the first 2 spots, first and third, or they could go in the last 2 spots. So there's actually 3 ways to do it. And then what's the other digit going to be? Well, it can't be 0, because we've already counted the 3 0 cases, but there's 9 other digits we could have, and so there's 9 numbers that go 5, 0, 0, something else. From 5001 to 5009. So there's 9 numbers here, 9 numbers here, and 9 numbers here. Okay, and they're all different, because they've got zeros in places that the others do not. Okay. What if we just had 1 0? I'm going to write 1 zeros just to be consistent. Well, again, we have to start with a 5. And we're going to make the rest of our 3 digits. But where does the 0 go? Well, you could go here, here, or here. And then we can have more numbers. They can't be zeros, because that would be covered by our previous cases. So how many digits could we have here? Well, we could have 9. Anything from 1 to 9 would do. And then we could also have 9 for the second one. Anything from 1 to 9 will do. So we actually get 81. 81 different numbers. Everything from 5,011 to 5,099, and not including the multiples of 10. Okay? We still have 9 choices. We get 9 choices for each star here. So we get 81 new numbers, and we can't have 0 zeros, because otherwise the product wouldn't be 0. So we get 2 plus 9 plus 9 plus 9, so that's 2 plus 27, that's 29. Plus 3 81s, that's 243. 243, and then plus 29 is going to be 2, carry the 1, 7, no carry, and a 2. So I'm going to say 272, and I didn't even need my calculator, and that's going to be D. So there we go. We broke it down into cases. We attacked them each methodically. We have all the possibilities laid out for us, and we just add things up at the end. Okay. Was there a faster way to do this? Not especially. But if you are looking to shortcut these things, well, we have 3 cases here, 3 cases here, but they all resulted in the same number. So if you wanted to break this down into a different style of counting problem, if you had 2 zeros, so I'm doing it slightly different, 2 zeros, I know that I have to choose one of these 3 spots will be not 0. So 1 of 3, so I've got 3 choices there. Once I choose which one is going to have the star, 3 choices there, times 9 different choices for what the star can be. I could get the 27 faster. I could also get the 243 faster. It's not that much of a time save, honestly, but if you're looking for those little things, there you go. So that's question number 19. We've got one more question to go in part B, and that's question 20. I will see you for that in the next video.